All right, now, understand that the Earth revolves around the sun. That means it goes around the sun counterclockwise. But it also rotates on its axis counterclockwise as well. Okay? The tilt of the Earth is 23.5 degrees. That's the tilt of the Earth, 23.5 degrees. And that tilt is a major contributor to our seasons here on Earth. Summer, winter, fall, and spring, which is what we're in right now. As it goes around the sun, the tilt remains in the same position all the way around its journey around the sun. The tilt doesn't point this way, and then as it gets here, point this way. The tilt stays the same all the way around the sun. That is another reason we have the 4 different seasons. Remember, rotation means around its axis. Another thing that we call rotation is a day. 1 day is the time it takes the planet to rotate once around its axis. Revolution is what we call a year. The time it takes for a planet to go once around the sun. Every planet has a rotation. Every planet has a revolution. Their times are not the same. Okay? Now, here's a picture of the Earth if it wasn't tilted. But they're just showing this for you so that you can see that the equator is going to get the most direct sunlight. Now notice, when sunlight hits something directly, it's going to heat up much more. So that's why in this area of the Earth, you're going to get a lot of dry, hot, arid climates. As you start going up towards the poles, the sunlight's going to get more deflected. So it's going to get colder and colder. That's why the closer you are to the poles, you have ice caps, because you don't get direct sunlight. You get deflected sunlight. And as you see, the Earth does go around with the axis in the same position all the way around. We're up in the northern hemisphere. That means up top over here. When our tilt is away from the sun, we get less direct sunlight, so that would be our winter. This is what we would call the winter solstice, and that happens around December 21st or December 22nd. Here, notice the tilt is still in the same direction, and both sides of the Earth are getting the exact same amount of sunlight. So you're going to have the equinox, meaning you're getting an equal amount. Okay, and you're getting about the same direct sunlight all the way around. A little bit less up towards the top, but better than over here. Now we're tilted towards the sun, so we're getting more daylight hours of sunlight. That's what we call the summer. That's why during the summer, you're going to have longer days than in the winter. Get about 15 hours of sunlight compared to in the winter, you only get about 8 because of that tilt. And also, we talked about it, there are some places on Earth during this time of year, like here in the South Pole, they have 30 days of complete darkness. And then up here in the Northern Pole, 30 days of complete daylight. It never gets dark. That can kind of confuse some people. And then we come back to the equinox again. So you have 2 solstices and 2 equinoxes. And also the height of the sun helps determine the angle of that sunlight hitting, so it'll help determine the seasons. So notice during the summer, the sun is much higher up, so we get more direct sunlight. During the winter, it's much lower down, so we get less direct sunlight. We talked about the astronomical unit. Once we get into outer space, we no longer use miles or kilometers. It just becomes way too big, right? The space between objects become way too vast, so we have to change it up a little bit. And that's what we use an astronomical unit for. Now, the pictures are only there to describe the size differences between the planets. That is not the real distances between the planets. The real distances are in this number line up here at the top. If you want to know, now remember, an astronomical unit is the distance between the Earth and the Sun. But that's not the astronomical unit. The astronomical unit we're looking for is right here, because that's where the Earth is compared to the Sun in this number line. That's tiny. And then right here is Mars, so it's a little bit farther than 1 astronomical unit, about 1.5. Those are the first 5 planets. Look how close they are together. Then we start getting farther and farther apart with our gas giants. 5 astronomical units away, 10 astronomical units away, 20 astronomical units away, 30 astronomical units away, and 40. Look how much farther apart those bigger giants are. Now, we as a human species have only traveled about right here. That's as far as our space exploration has gone. When you consider that entire number line, this is as far as we have gone. Barely anywhere. That's just to the moon. Now, I'm not talking about our probes that we've sent out. Those are robots. Those are machines. Humans have only gone to the moon. That's not very far when you talk about space exploration. And we talked about this, once again, mass and distance change gravity. The bigger the mass, the bigger the gravity. The shorter the distance, the bigger the gravity. So we talked about that. And we talked about that's why the moon orbits the Earth instead of being pulled in an orbit around the sun. It is actually going around the sun because the Earth is going around the sun and the moon follows the Earth. So it still is going around the sun. We talked about the moon rotating and revolving at the exact same speed, and that produces only one side of the moon being shown to us at a time. That means there's one side of the moon that the majority of us have never seen. When I say the majority of us, I mean those of us who did not go to the moon, which is the majority of us. We have not seen the other side of the moon. So we call it the dark side, the side we don't get to see. But if you notice, even the dark side, which is right there, even the dark side of the moon gets light. So we don't call it the dark side because it doesn't get sunlight. It does. It just means we don't ever see it. And in fact, on this side of the moon is a giant crater that looks like an eye. Could you imagine if that was facing towards the Earth? People would be like, uh-oh, the eye's watching us again. Okay, so good thing we just have the man in the moon. Some cultures call it the woman in the moon. Some cultures call it the animal up there in the moon. Depends what culture you come from. Because it goes around, it creates these different phases. Because there's only parts of the, remember, the moon doesn't create its own light. The moon is a gigantic bicycle reflector. It doesn't have its own source of light. It just reflects sunlight. So when we don't see the moon, it's still there. It's just the other side is getting the light and we don't get to see it. Remember, for extra credit, you can do the moon month calendar. You go outside, you look at the sky. Right now it's perfect timing because it's the very beginning of a moon month. Of the lunar month. There's no moon right now. It's a new moon. So if you go outside every day, no moon. All you got to do is put down the date. No moon. Look up. No moon. And eventually you'll start to see it waxing. Waxing means starting to grow. And you'll start off with a little sliver. We call that a quarter moon, right? A crescent moon. And then it'll go to a half moon. And then it'll go to a full moon. And then it should start waning, meaning getting smaller. But right now we are at this point in the lunar month, the very beginning. Perfect time to start. Yes. 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 Yes, you still have enough time to complete it as long as you start it before Monday. Or before this weekend, I should say. Okay. So if you notice, look how the moon goes around the Earth. Right? Here's the sun, and it only gets light from the sun. So when you're right here, the side facing us doesn't have any light to reflect. So we call that a new moon. And then it has a little bit of light to reflect, so we have that a crescent. And then a half moon, because half of it's lit, and we can see that half. And then we have a full moon, because this entire side is reflecting, and then it starts waning, meaning getting smaller, and back to that moon. It's all because of the reflection from the sun. And two awesome things happen when this is happening. We have sometimes when it's going around the Earth, it gets in the way of the sun. And it casts a shadow. And in fact, eclipse means to cast a shadow. And so you get a part of the moon getting in the way of sunlight during the day and casts a very small shadow on one tiny little part of the Earth. That's why total solar eclipses are so rare, because you have to be at the right place in the right time. They only last between 1 to 4 minutes normally. Some can last up to 7 minutes. That's a long solar eclipse. Okay? Question? Okay, now not every time it goes past the sun is it a solar eclipse, because the moon is at the revolution is kind of at a tilt, so it's basically always going to be lower than the between the Earth and the sun, or higher over here than the Earth and the sun. That's why they're still rare. It has to be a perfect alignment between the three objects. When it's on the other side at night, we call that a lunar eclipse. And lunar means at night, because lun means moon. Okay? And that's when the Earth casts a shadow on the moon. And that's what happened about 2 weeks ago. The Earth casted a shadow on the moon, and it ended up looking like a red blood moon. And that's because you have this penumbra up here still reflecting a little bit of light onto the moon, giving it that reddish effect. Okay? So even though it's in the shadow of the Earth, you still have a little bit of light that can still hit it a little bit, giving it a red hue. That's what we call it, a blood moon. It has nothing to do with evil. It just has to do with science. Make sure you know that the moon is involved with high tides and low tides. If you've ever been to the beach, you see signs that say when high tide is coming. High tide is when the water level rises. There are some beaches around California and all over the world that have sea caves. It's caves created by the waves, and you have these nice little caves you can go in and explore. But at the very front of the cave it says, beware, high tide comes in at 6 p.m. Please be sure to be out of here before then. Because if you get caught in a cave during high tide, you're just going to be trapped in the cave and drown. Because the water level is going to rise and cover the cave. So you have to be out. It happens twice a day. Because it happens not only on the side of the moon. Now remember, the moon has gravity, so it pulls the water up towards it a little bit. That's why you have a high tide. But you also have something called an opposite end bulge. And so it always happens here and here during the course of the day. And then if you go a little bit around the Earth, you have low tide on those sides. Okay, high tide and low tide caused by the moon and a little bit of the sun. And then finally, origin of the moon. There's been a lot of hypotheses over the years, but the one that's been sticking the most is that in the very beginning of the Earth's solar system, there were two objects forming very close together, the Earth and another object, and their revolutions around the sun crossed. And they crossed to a point where they collided with each other. And this collision sucked in all the heavy metals from that other object, like iron and all the heavy metals, and all the lighter elements created a disk around this planet, kind of like the ring of disks around Saturn. And then they eventually coalesced into an object all on their own, and we call that the moon. The reason this is the most widely accepted hypothesis is because when we went to the moon and grabbed some lunar rocks and studied them, the rocks up there are the same age as our oldest rocks down here. And so since they both formed at the same time, we assume they have to have collided around the same time. And so that's why we say that the moon collision theory is the best. Now, it was when it was first forming, so there was no life on the planet at this point. Okay? If there was any life forming, it was completely got demolished and it had to start all over again. But there is pretty much no life on the planet at that time. And just so you know the moon's size, if it crashed into the Earth, it would take out the entire United States, except a little bit of Florida, a little bit of Maine, and a little bit of Washington, and maybe a little bit of the coastline right there. but the entire United States would be taken out. That's how big the moon is. It's 1/6 the size of our planet. About the size of Mercury, actually. Mercury may be a little bit bigger, but it's about the same size. So that was what we did on Friday. Any questions on that stuff? Okay, take some time, look around with your neighbors, make sure you have everything filled in.